Saturn's rings look soft from a distance. Up close, they are a thin plain of moving ice. If you fall into them, speed becomes the weapon. People imagine the rings as a glittering ocean, a place you could drift through like slow snowfall. But the rings are not still, and you are not aligned. They orbit Saturn at enormous speed, like traffic on rails. Your path cuts across that flow, not along it. That mismatch turns small ice into high-energy shrapnel. In this tape, you will follow the real sequence: what hits first, what fails next, and what ends it. Not because Saturn is cruel, but because physics is. You are falling, but it does not feel like falling. There is no wind, no sound, no sense of down. Saturn fills half the sky, striped and unreal. Ahead, the rings stretch like a pale blade. They are bright because they are mostly water ice, and they are thin, far thinner than they look. That thinness is the trap. A thin sheet can still ruin you. A highway is thin too, until you step into it. The rings are a disk of countless particles. Some are dust, some are pebbles, some are boulders. They share an orbit, moving around Saturn together. But you are not one of them. You are an intruder with the wrong velocity. They are not a solid band you can land on. NASA describes them as billions of icy chunks. They range from tiny grains to mountain-sized pieces, and the dense rings can be only about 10 meters thick. Now add the number that matters most. Orbital speed in Saturn's main rings is extreme. Near the inner rings, particles move above 20 kilometers per second. Farther out, they still move around 17 kilometers per second. The exact value depends on distance from Saturn, but the scale never becomes gentle. Here is the crucial detail. If you fall into the rings, you cross the ring plane. You do not match the ring's circular orbit instantly. Your trajectory is different. Your speed is wrong. Even a small mismatch is lethal at these speeds. A grain of ice does not need mass, it needs velocity and a place to hit. From far away, the rings look empty, and in many regions they are. The particles are spread across a vast area. You might pass between pieces for a moment. That sounds like hope, but it is not safety. Because you do not need a wall to die. You need a single strike at the wrong angle. In spaceflight, tiny particles are already dangerous. A fleck of paint can puncture metal at orbital speed. Now replace paint with hard, cold ice. Replace one fleck with a constant field of debris. It becomes erosion, not impact, like sandblasting, but with bullets of frost. Cassini gave us a hint of that reality. When it crossed Saturn's ring plane, instruments registered intense dust hits, hundreds of impacts per second for minutes at a time. That was a spacecraft built for deep space, and it still treated ring crossings with caution. Your body is not built for that. A spacesuit is not built for that. The first few hits might not even feel dramatic. A sharp tap, a tremor, a jolt through the chest. Then a new sound begins inside your helmet, a hiss you cannot stop. The first puncture is small. It does not tear you in half. It attacks your pressure. Air leaks from a pinhole fast. Your suit stiffens, then softens as pressure drops. Your hands lose strength as the gloves deflate. Your breathing turns thin and urgent. You try to orient, but there is no stable reference. Saturn's rings have no up or down. More impacts follow. Not one clean collision, but a swarm of strikes. Each one chips material from the suit's outer layers. Each one widens weak points at seams and joints. Visor coatings craze with micro cracks. A crack becomes a fracture. A fracture becomes a split. Now the failure accelerates. You are still crossing the plane. You are still moving relative to the ring particles. The hits do not stop because you panic. They stop only when your path changes or you stop existing. A larger fragment arrives without warning. It does not need to be big. A pebble-sized piece at high relative speed is enough. It strikes the helmet rim, not the visor center. The helmet twists and the seal fails. Pressure drops to vacuum in seconds. Your vision narrows immediately. You cannot hold your breath long enough. Oxygen does not leave your lungs gently. It forces its way out as your body tries to equalize. You lose coordination, then consciousness, and the ring plane keeps working. Impact after impact, carving through fabric and insulation. Your body becomes exposed to vacuum and cold radiation. Not a clean freeze, not a peaceful drift, just rapid failure followed by continued abrasion. The rings do not swallow you like water, they shred you like a moving blade. If there is anything left, it does not stay with you. Ring particles do not collect debris like a net. Everything in that region obeys orbital mechanics. Fragments spread along paths shaped by Saturn's gravity. Some pieces spiral inward over time. Some are kicked outward by collisions. Most become part of the noise. This is the quiet horror of the rings. They are beautiful because they are broken. They shine because light hits countless icy surfaces. But close up, it is a collision ecosystem. A thin plane where motion never stops. Science you can hear, dread you can feel. So here is the only real takeaway. The rings are not a place to fall. They are a place to intersect. And intersections at orbital speed do not forgive. From Earth, Saturn's rings look calm. A symbol, a halo, a promise of order. But their order is speed, and their law is impact. Even if the space looks empty at first, it is not safe. Because one fragment is enough, and many are inevitable. If you want the next tape, subscribe. The archive keeps growing. And the next time you see Saturn in a photo, remember, that bright line is not softness. It is motion, frozen into a razor-thin plane.